So we had been given the opportunity to use the MX10 detector CERN chip to conduct an experiment of our choice, in which we recorded the levels of radiation in foods of our choice. We wanted to see if we were exposing ourselves to high levels of radiation, and if so, how this could affect our bodies. With the software, we measured alpha, beta, gamma, muons, and proton levels and compared the food's radiation levels.
Our main aims were to discover if there was an increased level in foods compared to just the background radiation, and secondly, to find out which would be the most radioactive food and if any could potentially cause any damage.
So we researched before we started some of the most radioactive foods and eventually decided to use walnuts, carrots, apples, cucumber and bananas, as all of these foods are also fairly common. In order to do this, we used the MX10 detector CERN chip attached to a laptop installed with the Pixelman software. This took 40-second frames for 30 minutes.
Initially, we took the background radiation in our school lab as a control. However, the readings were a lot higher than we anticipated, and this is probably due to the fact that there was a radiation cupboard right next to our lab.
We clamped the foods and tested them close to the detector to ensure most of the radiation, especially alpha and beta, were still detected. The distance between the chip and the food was also kept constant to keep the test fair.
In order to get a high accuracy of results, we would take more repeats in the future to see if our results were reproducible. However, we struggled with repeats as each reading took a long time to complete, and we had restrictions on the equipment available for us.
Before we conducted the experiment, we expected bananas to be the most radioactive food. However, we found out that cucumbers were in fact the most radioactive, and we think that this could be due to where they were grown and the water used to grow it.
The levels of alpha and beta particles present would not be greatly affected by varying levels of background radiation we measured, as they can't travel that far in air, so it would have only come from a food source placed next to the chip, unless there was another source we hadn't detected yet in the lab. We got together weekly in order to carry out the project, and this meant readings were taken over a long period of time, which similarly could have affected our results.
From our results, we planned to find out if any of the foods could damage us. And we found out that our results showed that there was some radiation in the foods. However, they were not significant enough in order to affect us, and the amount that we consume will not hurt us.
The highest level of alpha were picked up in bananas and cucumbers. Although alpha is the most ionizing, it is unable to travel far in the body if ingested, so there's no harm beyond the location of the source. Some of the foods may have had higher levels than expected. A cause for this is the water concentration in cucumber and apples, with 96% and 86% respectively of their total mass being water. This would increase levels of radiation detected, as water can carry radiation. Moreover, this could explain why we got different levels of radiations for food, as they were not all sourced from the same place and treated under the same procedures once uprooted.
We experience lots of radiation every day, with our bodies picking up radiation from the air we breathe, the water we drink, the different places we travel, and from medical and security scans. We found unexpected levels of protons in our readings. However, this may have been a fault with the CERN chip, as it is possible that that muons were detected as protons. And we can't really get proton levels detected, as the Earth's magnetic field kind of deflects them. And another group at a different conference discovered the same issue.
We feel that there are opportunities for further investigation of food grown in different locations around the world to see whether the ways food is processed and transported affects radiation levels. Our research has shown that water had high levels of radiation, so it would be interesting to research the way that food is processed and transported and how it affects it. This would help us to understand anomalies in our results. For example, the strange results we got from our carrots, which could have been treated in a location of high radiation. This helps us properly evaluate whether the water level was the cause of our two highest radiation foods.
From our research, we found radiation can ionize atoms, and we also found that when ingested or inhaled, radiation can damage internal tissues as energy damages the chemical bonds in your bodies. Some radiation is able to destroy the nuclei of atoms, and a buildup of this damage can cause radiation sickness.
From our previous knowledge, we knew that alpha is not normally considered dangerous externally, as it's stopped from penetrating the skin. However, if inhaled or ingested, it can be very dangerous, as it can cause mutations in our cells which can lead to lung cancer. In the foods we researched, the levels of alpha radiation emitted were significantly comparatively. Beta particles are about 8,000 times smaller than alpha particles, meaning they can penetrate the skin, and an external exposure causes burns, tissue damage, and radiation sickness. Beta particle emitters can enter food and water and can be consumed by humans. If actually ingested, beta particles have much more severe symptoms.
Gamma rays are considered very dangerous as they can move through many materials and require a thick layer of lead to stop this. This means that they can pass through your body and cause widespread damage in large quantities. This is one of the reasons that X-rays per year are limited.
So, how does radiation actually affect our bodies? Exposure to high levels of radiation causes immediate health damages such as nausea, vomiting, and skin burns. It also increases the likelihood of cancer and cardiovascular disease and can ultimately potentially result in death. Exposure to low levels of radiation has no immediate effect but can increase the risk of cancer as the DNA in that person has been damaged. And thank you for listening, and thank you again to Iris for enabling us to carry this out.
I was just wondering, what's the distinction between electrons and beta that you were observing there?
The distinction is that electrons tend to be lower energy, than beta. Beta is still electrons. It's just they're higher energy.
Okay, thank you.
Could you just put your results into context for me? I noticed the sort of y-axis was 10, 15 in terms of your counts. What would be a number that would be a dangerous number for a count of radiation?
Did you do it with any sources? You do it.
So I think that's something.
I think on the internet we kind of researched it, but it was in like a different unit, so it wasn't very comparable because this was more a kind of count of the like beta or gamma, whereas on the internet it takes it in like a different unit, I think. So it wasn't quite that easy to compare, but this was a low level because it was